Welcome to Lesson 7 of Unit 2, U.S. Traditional Multiplication, Part 3. We've had Part 1 and 2 already, along with some conversion practice in the previous lesson. Today, we're going to be able to use U.S. Traditional Multiplication to multiply two-digit numbers by two-digit numbers. We're going to be able to write and interpret numerical expressions, and we're also going to be able to perform operations with multi-digit whole numbers and decimals to the hundredths. Little vocabulary review is the area model. Remember, that is a model for multiplication problems in which the length and the width of a rectangle represent the factors and the area of a rectangle represents the product. So here's that example. This would be a 3 by 5 or 3 times 5. So suppose you already figured out that 54 times 8 equals 432. We practiced that in the first two lessons. How could you use what you know there to help you with solve 54 times 18? Here's an area model representing 54 times 18. We can do 54 times 8, and then we can do 54 times 10. Remember, the model divides the product into two parts, very similar to partial. 54 times 18 is the same as saying 54 times 10 plus 54 times 8, which means that the two products can be calculated separately and then added to determine the final answer. You're going to apply this idea when you use the U.S. traditional multiplication to multiply by two-digit numbers. So in today's lesson, we're going to learn to use that U.S. traditional multiplication that we did in 2 by 1 or 3 by 1, 4 by 1 to do two-digit numbers, and you're going to use the area model to help explain why it works. So here's an example, 37 times 25. It's asked us, how does this area model show 37 times 25? Well, when we take a look at this, we've got our 37 times 20 and then 5. 37 times 25. So looking at it as a U.S. traditional two-digit by two-digit, we're going to take a look at each step individually. On the right-hand side is the work, and then on the left-hand side, like in the previous lessons, we have the steps written out. Follow along. So 37 times 25. Our first step is to multiply 37 by 5. And I'll highlight this for you. We're going to do 37 times 5 in the 25, as if the problem were simply 37 times 5. We know that we take 5 times 7 ones, and we get 35 ones, or 3 tens and 5 ones. You're going to write that 5 in the ones column and the 3 above the tens column. Then you're going to take 5 times 3 tens, which is 15 tens, but then you're going to add on that 3 tens to come up with 18. So you get 185. 100, 8 tens, 5 ones. The next step here, just to show you, is comparing this to the area model. So we've got 37 times 5 was 185 right there. And we can see that right here is that 185, which is right here. Now, we're going to move on to step 2. And you can see that we've dropped down a line here. We were finished with this line. We're now moving on to this line right here. Sorry. Step 2, think about this. What is the value of the 2 in 25? Well, it's worth 20. So we're actually multiplying 37 times 20 as if the problem were 37 times 20. We're done with this 5 here. We're finished. So you're going to take 20 times 7 ones, which is 140 ones, or 100 4 tens and 0 ones. So you're going to write a 0 in that ones column. And then you're going to write a 1 up here above the tens. Remember, that 1 represents 100. Okay, so then we've got our 4 right here. So 140. And then you're going to take 20 times 3 tens, or 60 tens, or 600s. So you're going to take 2 times 3 is 6, plus that 1, which is 700. So you get 740. So when we compare that to the area model, you've got 37 times 20 equals 740. We've got our 2 parts to the area model finished. And what do we normally do with these 2 numbers when we're doing the area model? That's right, we add them. So step 3 is to add the products from steps 1 and 2. So you're going to take 185 plus 740, and you get 925. So let's try these. So I want you to do them as area models. First, I want you to try 73 times 42 and 89 times 11. Pause your video and then come back and check your work. Okay, so I have gone to the screen so that we can look at the answers. First, you would take 73 times 2. And when you take 73 times 2, we should get 146. And then 73 times 40, you should get 2,920. So you're going to take 2,920 plus 146 and getting a total answer of 3,066. Moving over to 89 times 11, well, you should have 89 times 10, 89 times 1. We know that 89 times 1 is 89. And we know that 89 times 10 should just be that with a 0 added to the end, so 890. And then again, we're going to add those 2 together, getting a final answer of 979. So look at your work that you just did. Did you notice any patterns or similarity in the problems? Understanding these patterns, such as the one that can help you catch mistakes and check your work when you are using U.S. traditional. I've talked about previously that it's okay to check your work using lattice. And we didn't use lattice today, but we used the area model. It's okay to check your work. Try it in traditional and then check your work using one of those previous multiplication strategies that we've learned in the past to check. Making an estimate is often the easiest and most reliable way to check. But because U.S. traditional multiplication is new to you, we might make mistakes easily. So again, using the estimation to check your reasonableness, but then using lattice or using the area model, using partial products, is a perfect way to check your work. Open up your journal to page 54. We're going to take a look at the example. I'm going to do number 1, and then you're going to do the rest of the problems. So looking at number 1, it says, first of all, let's look at our directions. Make an estimate. Write a number model to show how you estimated. Solve using U.S. traditional multiplication. Don't forget to show your work. And use your estimate to check whether your answer makes sense. So the example is 76 times 24. We're going to estimate 80 times 20 equals 1,600. We rounded 76 to 80 and 24 to 20. We know that 8 times 2 is 16, and then we add on those 2 zeros at the end. Our estimate is 1,600. Take a look at the work right here. They did 6 times 4 was 24. Then 7 times 4 was 28 plus that 2, and we got 304. Moving over to the 2, we know that's actually worth 20. So you're taking 20 times 6, which is going to be 120. So I can see that I've got the 0 here, the 2 here, and the 1 up here, 120. And then moving over, the 2 times 4 is actually like 20 times 70, which is 140. But can't forget that 1. That's 150. So 1520. And then we add that up. So that's 4, 2, 5, and 3 is 8, and then 1. The answer is 1,824. Does that make sense? Is it logical when you compare it to 1,600? Yes, that answer makes sense. Now let's look at number 1 together. 31 times 43. So same thing. I'm going to write it over here, though, for more space since we can see it better. I'm going to rewrite it like they did. 31 times 43. And we're writing it vertically. Okay, they write it horizontally at first, and then we do our work vertically. So for the first one, I'm going to take 3 times 1, which is 3. And then 3 times, I don't have to carry anything. So 3 times 3 is 9. Okay, I'm done with that 3. I can go ahead and cross that out because I'm done. Now, something I want to show you is we know that we're going to be doing 40 times 1. So I know that it's automatically going to put a 0 in this place. So I'm just going to go ahead and do that. Now I can just think of it as 4 times 1. So 4 times 1 is 4. And then I can just do 4 times 3, which is 12. It automatically, by putting that 0 there, because I've moved over one place value, it allows me, and I put that 0 to move over one place value, I can then just multiply the numbers as I would normally. Remember that the next step is to take the 2 partial products, the 2 products there, 93 and 1,240, and we're going to add. So we've got 3 plus 0 is 3. 9 plus 4 is 13. 2 plus 1 is 3. And then we have 1. So our answer should be 1,333. And you can see here, the estimate would be 30 times 40, because 31 can round to 30, 43 to 40. The estimate would be 1,200. Does that make sense with my answer? Yes, it does. So now it's your turn to do 26 times 16. Don't forget to estimate first. 3 is 87 times 46. Then moving over to 4 and 5. Number 4, I want you to explain how your estimate helps you check whether your answer in problem 1 makes sense. And then 5, complete the area model. Explain how it relates to your work in problem number 3. Okay, pause and then come back. Don't forget that you can look in your SRB. Okay, that's called Introducing Multiplication Bullseye. But complete problems 2, 3, 4, and 5, and then come back. All right, problem 2, 26 times 16. We could round that to 25. You could have rounded it to 30 as well, whichever way you did, and then 16 would be rounded to 20. So your estimate should be somewhere around 500. And then you can see the work here. You should have gotten the answer of 416. If you checked your work with lattice, if you checked your work with area model, perfect, because that is what we've been talking about. Not only the estimate to check your reasonableness, but also checking your actual work using one of those other methods is a perfect way to check your work, to check your correctness. Number 3, 87 can round to 90. 46 can round to 50, getting an estimate of 4,500. And again, if you solve this correctly using the US, 4,002. 4,002 should be your final answer. And then for 4 and 5, let me erase that so we can see better. Let's take a look at what they said. So a sample is that the estimate was 1,200 or 1,200, and your answer is 1,333. Those numbers are pretty close to each other, and it makes your answer make sense. It makes sense. Remember the estimate. When you estimate, you make an estimate, it's checking if it's logical, if it's reasonable, if it makes sense. That's all we're looking for there. And then finally, for problem number 3, the area of the right side of the rectangle is your first partial product, or 522. The area to the left side is the second one, it's 3,480. And then you just add those together. Okay, that's how it relates to your work on this one. So you are finished with lesson 2.7. It is time to do your independent work. However, before you move on, it's not required, but it is a great chance to get some practice. And it is home link 2.7. You see you have way more problems to practice and to check out, just to get a better grip of 2x2 multiplication. You also have that practice at the bottom that works on those powers of 10. This is a great chance to keep practicing, and that way if you have questions, you can use these to guide your questions to me and to get more practice. Remember, today we were using U.S. traditional multiplication to multiply 2-digit numbers by 2-digit numbers, write and interpret numerical expressions, and also perform those operations with multi-digit whole numbers. Like I said, head back to the campus, work on independent work 2.7.